Alright, what's up guys? In this video, we're going to pick with some vector calculus here. We're going to evaluate a surface integral. So I'm going to evaluate the surface integral z ds, where s is the surface given by x is equal to y plus 2z squared. And then we're given the range for y and then for z. So in this case, notice that we're given basically the surface s here in the yz plane because we have x is equal to g of y comma z. That's given to us. So let me just quickly write down the definition for the surface integral and how we're going to evaluate it. And keep in mind that the definition for the surface integral will change depending on what plane you're in. So in our case, we're talking about the YZ plane. So the surface integral in this case, by definition, will be the surface integral f of x comma y comma z ds is equal to the double integral, and we'll have f of g of y comma z comma y comma z multiplied by the square root of the partial of x with respect to y squared plus the partial of x with respect to z squared, and then plus 1 and then dA. So this would be the definition for the surface integral. Alright, so let's go through and get all the stuff that we need. So we need the partial of x with respect to y. So we just go up here to x is equal to y plus 2z squared, take the partial with respect to y, then we take the partial with respect to z. So we take the partial with respect to y, we'll get 1, and then if we go the partial of x with respect to z, we'll get 4z. Okay. Then just go back to setting up the surface integral. So we got the surface integral z ds is equal to the double integral, and we got z, and then we'll have the square root, and we'll just need to plug everything in. So I'll write everything out. It's going to be 1 squared plus 4z squared plus 1 and then dA. Okay, all right, so here's what you got now. So we're going to evaluate this dz dy. So this would be from 0 to 1, and we still got z, and we got the square root of 1 plus 16z squared plus another 1, and then this would be dz dy. Now we can simplify and try to take care of that square root so that it's not causing any issues. Okay, so we know that 1 plus 1 is 2, so essentially what we would have here is basically 2 plus 16z squared. I can actually simplify that. If I take the square root of 16z squared, I'll get 4z, and I'll still have a square root of 2, but I can bring that out in front of the double integral itself. Now notice that when I simplify this down to 4z squared, I still do have a z right there, so this would be, 4z, then I'll still have a z right there, so this would be 4z times z, which is 4z squared, and I can bring the square root of 2 out front. So this would be the square root of 2 from 0 to 1, and this would be 4z squared, and this would be dz dy. Okay, so hopefully you are with me so far. And then it's just a double integral basically. All right, so I'll break it up into steps like I normally do. So this would be from 0 to 1. You can pull the 4 out. This is this is z squared dz, because we're integrating respect to z first. So this would give us 4. This would be z cubed over 3. And this is going to be from 0 to 1. So this is clearly just going to give us 4/3. Because when we evaluate from 0 to 1, we'll just get 1/3 multiplied by the constant that's on the outside, which would be the 4. And that's what we'll have. So then we'll go to the last integral. Now remember, since 4/3 a constant, I can pull it out. So essentially when we get to the last variable, we're just going to be integrating dy, really. We don't have to keep the 4/3 in there because that's a constant. And that's what we got when we integrated respect to z to begin with. Okay. So we know that this is just going to give us 1. So we'll have basically the square root of 2 times 4/3 multiplied by 1. And if you do that, you'll get 4 times the square root of 2 divided by 3, which is the actual answer. So your final answer for this surface integral is going to end up being 4 times the square root of 2 divided by 3. That's the answer. All right, so let me circle that for you. And if you have any questions about how I arrived at my answer, please let me know. But that is how you evaluate the following surface integral. All right, guys, I'll see y'all next time. Y'all take care.